Okay. Okay, in the last class we have studied about the difference between MPFI and CRDA engines. So we studied about also we studied about the difference between the carburetor and fuel injection systems. Then we saw how the combustion in a diesel engine occurs, and I have told you what are the uh, how the combustion in diesel engine takes place and how the CRDA works. So the CRDA is based upon a diesel engine, and CRDA technology is used in diesel engines. So we had to know the working of diesel engines. Hence, I have showed you the video relating the combustion that takes place inside a diesel engine. So here you can also see the fuel spray here. There is about six sprays from six hole nozzle, and that is being combusted at the power stroke. That is what you have been seeing here. And then there is the exhaust. You can also see a slight swirl inside. That is a swirl. There is a mixing of the fuel and the air inside the combustion chamber. So it is rotating in such a manner. You can see a small rotation of the fuel. That is because of the swirling air during intake. So the air intake is provided in such a way that swirl occurs inside the cylinder. So two factors influence the movement of air inside the cylinder. One is the air flow from the inlet valve. That is, if you are sending the air in a vertical axis, swirl will be much less. While if you are sending it in a horizontal axis, also swirl will not occur. So you can see in this diagram itself, you can see here in the diagram itself, the pathway is kept inclined rather than the exhaust. See, the exhaust is in horizontal direction, while the pathway for the inlet valve or the intake valve is kept at an inclined portion. Okay, this facilitates the air to enter in a swirling motion. So it will come like this, hit this wall, and then moves like this. Okay, that is one of the factors influencing the airflow. Another factor is the shape of the piston head. Okay, I have shown you many pistons and pistons with the holes, domes, and such shapes. So this shape also assists in the formation of swirl inside the cylinder. This facilitates mixing of so this swirl in turn, when we spray the fuel is then moved along with the swirl. So the air is rotating inside of the cylinder, and this air carries the fuel along with it in a swirl motion, so as to mix the fuel and air effectively and provide the combustion that we require. So once the spray is sprayed inside, it immediately mixes with the air and then combusts. So it combusts by means of the high temperature and pressure generated inside the cylinder. Okay, so that was what we studied in the last class, and some points I have not said in the last class, so I have added for the combustion of diesel engine. Next, we have seen three. I briefly explained naturally aspirated engine, supercharged engine, and turbocharged engine. So, in naturally aspirated engine is nothing but the engine where the air is sucked into the cylinder by means of atmospheric pressure itself. So, based on atmospheric pressure, so I have explained to you in the last class. So, during suction stroke, the piston moves from TDC to BDC. Once that happens, the pressure inside the cylinder will be less than atmospheric pressure. So atmospheric pressure is present at a higher pressure than that pressure that is existing inside the cylinder. So naturally, anything at atmospheric pressure can move towards the region of low pressure. So the air is present at atmospheric pressure at the inlet valve. So once the inlet valve is opened, so during suction stroke, the inlet valve is being opened, and once that inlet valve is opened, the air at atmospheric pressure is rushed into or sucked into the cylinder by means of this pressure difference. Okay, it is the same principle as that of a syringe. We have seen a syringe. So what we are doing is that when we pull the plunger of the syringe, inside the syringe, a region of low pressure is created. Okay, and to fill that to fill that region of low pressure, air from the atmosphere, that is at atmospheric pressure, rushes into the syringe. The same function occurs in a engine. So this type of engines are called as naturally aspirated engine, wherein it solely depends on the difference in pressures for combustion, for the intake of air. Okay, naturally aspirated. Aspirated means aspiration is same as that of respiration. Uh, Breathing, it is called naturally breathing engine. Okay, it's a kind of breathing, so it is taking in air, same as that what we are doing. We are inhaling air. Okay, same thing is occurring inside the engine. Next, there are two types of terms I had told you: supercharger and turbocharger. This is the schematic diagram of a supercharger. So you can see here how is the supercharger connected. It is connected to a compressor here, a compressor which is then coupled to a belt drive that is coming from the engine. Okay, this is the engine crankshaft. So we shown you what is the crankshaft. And the crankshaft flywheel is present here. The other is used for the other end is used for camshaft driving also. Okay, camshaft driving is there. So if the camshaft driving is there, there is another point here also. Okay, so there will be another sprocket wheel provided here with another belt drive for the camshaft. In the same way, one another sprocket wheel also is provided for running the compressor in the case of supercharger. So this is then coupled to the compressor, and from this compressor is nothing but a fan with a vane, and due to the rotational motion generated inside, in the principle of an exhaust gas. So what happens in an exhaust gas, sorry, the principle of an exhaust fan. Okay, and the exhaust fan, what it is doing, it rotates and pulls the air present inside the room and expels it outside. That is what an exhaust fan does. In the same way, the compressor of a supercharger or the supercharger itself has a vane which rotates by the power provided by this belt drive, and it sucks in the air from the atmosphere, compresses it, and sends it to the engine. Okay, it compresses the air coming inside. You can see the fresh air coming here. It compresses it and then sends it inside. So what is the advantage of compressing the air? So you have studied about so you have heard about LPG, that is liquid petroleum gas, and CNG, that is compressed natural gas. So what is the need for liquefying the petroleum or compressing the natural gas? It is nothing but liquefying petroleum gas holds more volume than the petrol present in the gaseous state. Okay, so when you are storing the petroleum, to store it more, if you want to store it, if you want to store more amount of petrol, Rather than in the gaseous state, you can store it more in the liquid state. And even more, you can store it in the solid form. So that is how the state of matters, we have studied about the state of matters, and the most freely escaping and the most freely independent is the gaseous state. Then comes the liquid state, then comes the solid. So more volume will be present for solid state, then comes the liquid state, then comes the gaseous state. In the same way, if we are compressing the air here, so compressing in the means it is being compressed not into liquid, but still it is being compressed. So compressing it reduces the amount of air, or the reduces the independency of air and holds more volume of air. That is what a compressor does. Okay, when more volume of air is then being supplied into the cylinder, we will get much cleaner combustion and also more power. More power will be generated. For that purpose, a supercharger is used. So you can see the effects of a supercharger when you drive a supercharged vehicle. You can see that even when we are taking the vehicle from a rest, that is at the first gear condition, you can see significant power increase when we give the accelerator. The vehicle can jump, okay, due to the excess power that is generated. But the problem is that it takes the drive from the engine, so less efficiency is being utilized. Okay, the power that is that we obtain at the wheels will be much lesser than a conventional engine, due to the presence of taking this power from the engine itself. That is the only drawback of a supercharger. Next comes the types of supercharger. So there are some types of supercharger, and these are root supercharger, twin screw supercharger, and centrifugal supercharger. So these are nothing, but these are the three types of superchargers. So Rhodes supercharger, or I will explain to you twin supercharger. So this is a twin screw supercharger. So it is in the shape of a screw, a helical screw. You can see it like this, and it is coupled to the shaft here. So one rotation of this shaft will facilitate the rotation of this screw itself due to the engagement or the meshing of these two screws. So if this screw rotates, this also rotates. Okay, so the air is sucked from this way. Okay, air is sucked through here and then discharged to here, to where the compressed air is going. Okay, you can see how the air comes in, and then so the screw is rotating, this one in the anti-clockwise direction and this one in the clockwise direction. Okay, that is how it is rotating, and air enters and discharges here. So the screw movement is significantly low when compared to the other two methods. So these are also used, these three types are used. Most commonly used is the centrifugal supercharger. Okay, next one is the roots supercharger. So I have shown you how the roots supercharger is being seen. So this is the root section. You can see how it is shaped in a specific manner. It is shaped almost as same as of this thing. This is called a spinner. You have seen it as a toy and all, and this is a spinner. In the shape of this spinner itself, the roots veins are provided. This is the roots veins. So these are also meshed in together like the twin screw supercharger, and this then rotates to form the supercharger discharge. Okay, then comes the centrifugal supercharger. So in centrifugal supercharger, this is the most commonly used type of supercharger. So what happens is, you can see the air intake and the exit. Okay, there is a vane or a turbine provided here, this compressor or this turbine works by coupling it with the, this end will be coupled with the engine, and once the engine rotates, this fan or vane or turbine rotates, and on rotation it sucks in air and swirl it at a high speed, increasing or compressing the air and increasing the amount of volume of air, and then discharging it to this side. Okay, this is how a centrifugal supercharger works. So it is using centrifugal force, so it is rotating, and by rotation it provides centrifugal force and expels the air by the centrifugal action through this discharge side. So these are the three types of supercharger. So you can see how the supercharger works here. So this is a centrifugal type. So the air is sucked in and it is expelled outside, as you can see here. Okay, this is a twin screw method. See, you can see a twin screw supercharger. So this twin screw supercharger inhales the air, compresses it, and gives it through the inlet manifold. You can see it here, and it is going into the cylinder. So this is a V-type engine with the 6 cylinders. Okay, V-type engine with 6 cylinders. You can see three here, and also there is three here, and so 3 cylinders it is supplying here. See, you can see it here. Some are going here, some are going here. These are compressed air that is supplied into the engine. So this is a twin screw supercharger. This is the centrifugal working of a centrifugal supercharger. Okay. Next is the turbocharged engine. So in a turbocharged engine, it is different from a supercharged engine where it draws power from the engine itself. But in a turbocharged engine, the engine, uh, the inlet manifold is shown here, the exhaust manifold is shown here, and it works solely on base of exhaust gas. Okay, it is nothing but a compressor and a turbine coupled together, and this turbine is provided here at the exhaust manifold, and this compressor is provided before the inlet manifold. Okay, so once exhaust gas exiting from the exhaust manifold strikes the vanes of the turbine rotates. Okay, this rotation facilitates the rotation of the compressor provided here. Okay, the compressor also rotates. This inhales the fresh air and compresses it and send it to the inlet manifold. So I can see another component here which is called as a intercooler, and this intercooler is provided for lowering the temperature of air that is coming from the compressor. So why do we have to lower the temperature? We are lowering the temperature so as to uh, reduce the temperature and increase the volumetric efficiency of the engine. So what is volumetric efficiency? If more amount of air is being breathed or inhaled into the engine, then the volumetric efficiency is higher. So that means the more the volume of air is entering into the cylinder. Okay, so the air that is being inhaled through the compressor will be much, once it is being compressed it will become hotter. Okay, hotter in the sense because the exhaust gas will be at a higher temperature, and this temperature will be transferred to the turbine, and the turbine is coupled to the compressor, and this coupling results in naturally results in the temperature of the compressor being higher, and this higher temperature affects the temperature of air, which will be also higher due to the temperature at the compressor and also due to the compression pressure. Due to two factors, the temperature of air increases, and this air has to be cooled down by means of an intercooler, which is nothing but the same as that of a radiator function, and then it is being supplied into the cylinder by means of the intake manifold. Okay, this is how it works. So the turbocharger is an improvement of a supercharger. So it does not take the engine power itself, but the exhaust, which is a byproduct which we don't require and we are utilizing it. So it is a positive type of charging method. But the only problem of turbocharger is that turbocharger solely depends upon exhaust gas. So at the situation of rest, so when the vehicle is at rest or starting from rest, the exhaust gas generation and the temperature of exhaust gas will be significantly low. Okay, so to start a turbocharger, it takes some time. Once sufficient exhaust is developed and the flow of exhaust is much faster, and also if the temperature of exhaust is higher. So these three factors depend for starting of turbocharger. Okay, that is the only difference of a turbocharger. So you can see how the working of turbocharger is taking place. So this is how it is taking place. Um, the air is inhaled through this, so you don't have to look at the rotation. Okay, I'm just telling you how the working is occurring. So the air enters here, it goes to this part is the intercooler, goes there and into the intake manifold into the cylinder. Okay, the exhaust gas which is passing through the exhaust manifold enters the turbine. This is a turbine here, and at the turbine, it rotates the turbine and provides power to the compressor, and the compressor in turn compresses the air and send it to the engine. This is how the turbocharger works. So I can see how the turbocharger is working here. So you can see there is a four cylinders, and from these four cylinders, exhaust are collected, and this exhaust will be passed to the turbine. This is the turbine portion of the engine. So you can see at a time one exhaust is only coming out. Okay, I have told you before itself. At each cylinder, different strokes occur. So only at a time, one cylinder has exhaust gas. Exhaust gas is generated. Okay, this exhaust is then transferred to the turbine, and this turbine rotates, and this rotation in turn rotates the compressor here. Okay, this is the air filter, and the filtered air is then passed to the compressor. This is a centrifugal type compressor, or a centrifugal type centrifugal type of compressor provided coupled with the turbine, and then this is compressed and sent to the inlet manifold. From the inlet manifold it goes into the cylinder. Okay, so you can see there are two ports here. Okay, inlet valve, there are two ports here. So significantly higher amount of air is entering into the cylinder. Okay, this is how a turbocharger and supercharger works. So this is another uh, I'll show. This is another turbocharger working. So you can see how the air swirls. This is the exhaust. This red part is the exhaust. So the exhaust gas is applied like this. So you can see how it rotates the fan and the turbine, and the compressor works, and the compressor sucks in air through this part and sends it to the inlet manifold. This is how it works here. Next is the turbo lag. So what is the turbo lag? I have explained it before. Initial starting of a turbocharger is very uh, very hard. So initial starting, such as the exhaust gas has to be supplied at sufficient temperature and velocity for turbocharger to start. Up, Apart from that, turbo lag is the time required to change power up output in response to throttle change, noticed as a hesitation or slowed throttle response when accelerating as compared to a naturally aspirated engine. So in a naturally aspirated engine, we are getting the power based on the accelerator pedal itself. Okay, but when using a turbocharger, the problem is that we will notice that when we press the pedal itself, there is a lag. The power to reach the engine, the engine power to reach the wheels, or we will notice a lag. And after this lag period is completed, you'll see the vehicle jumps forward. So if you have driven a turbocharged vehicle, you will notice this difference. Okay, not a significantly powerful turbocharger, but a lower. You can see in sufficient vehicles and all, you can see that turbocharger activates at about 2000 rpm to 3000 rpm in vehicles. Okay, not immediately itself, but powerful turbocharger will start at a higher uh, at a higher lower gear, that is first gear itself, turbocharger activates. But in smaller engines and all, turbocharger lag can be significantly observed. Okay, these are due to inertia, friction and compression load. Okay, compressor load. So exhaust gas, I have already told you, single cylinder is being used for at a time produces exhaust instead. But in the case of a 16 cylinder engine or a 12 cylinder engine, 8 cylinder engines, two cylinders may provide significant exhaust so as to run the turbine. But a single exhaust provides only sufficient power, and the load to run this compressor is much higher. Okay, due to being a metallic part, the load will be much higher for the compressor to run. So significantly friction and inertia will be high. Okay, inertia at rest will be very high. Friction, so it has to start running, so that will also be high. So due to these factors, turbo lag is observed. Okay, the difference between supercharger and turbocharger, I'll explain it in the next class.